to discuss to you dipole-dipole forces and dipole-dipole interactions. What is dipole? Dipole is a polarized molecule having partially positive and partially negative poles. Let's take a single molecule of hydrogen fluoride. This hydrogen fluoride share one pair of electrons. It is formed through a covalent band. Since fluorine is more electronegative than hydrogen, it pulls the share of electrons towards itself. Electronic clouds also tilt towards fluorine. As a result, partially negative appears on fluorine and partially positive appears on hydrogen. Take note that this is a single molecule with two poles. Due to electronegativity difference, there are now two poles that were created. It is now called dipole, positive pole and negative pole. Therefore, the single molecule of hydrogen fluoride is dipole. Dipole because it has two poles, the positive pole and the negative pole. What about a single molecule of chlorine gas? Is it a dipole? Because the chlorine atoms on either side pull the shared electrons equally, then it cannot be considered a dipole. There is no poles created between this molecule. As a result of this, no partial negative charge and no partial positive charge appear on either side. Therefore, a chlorine molecule is not a dipole. Chlorine molecule is not a dipole because it has no positive pole and no negative pole. How about dipole-dipole force and dipole-dipole interactions? Consider two molecules of hydrogen fluoride. There are now two dipoles. The positive pole of this molecule attracts the negative pole of this molecule. This is the positive and this is the negative. The negative end of this molecule, which is fluorine side, attracts the positive end of this molecule, which is on the hydrogen side. The force generated by these two dipoles is called dipole-dipole force. Since there is interaction of forces between two dipoles, it is called dipole-dipole interaction. Dipole-dipole interaction is represented by a broken line. Let's analyze the molecule of sulfur dioxide. Oxygen is more electronegative than sulfur. So partially negative charge appears on oxygen and partially positive charge appears on sulfur. How about if another molecule of sulfur dioxide is brought near with each other? The negative charge of one molecule will attract the positive charge of the other molecule. Dipole-dipole force is not a chemical bond. It is an intermolecular force. It is intermolecular because it comes from the force of attraction comes from two molecules. Dipole-dipole force exists only in polar covalents like hydrochloric acid, sulfur dioxide. Dipole-dipole force does not exist in non-polar covalents like chlorine 2 and oxygen 2. It is because these molecules of chlorine 2 and oxygen 2 are attracting the electrons of each side equally. Therefore, there is no charge that is being formed or created. Dipole-dipole force exists in polar covalents and does not exist in non-polar covalents. It is also a weak kind of force. It is because it is not made of a chemical bond, but rather it is made of an intermolecular force. Let's go to the summary. Dipole-dipole forces are attracted forces between the positive end of one polar molecule and the negative end of another polar molecule. They are much weaker than ionic or covalent bonds and have a significant effect only when the molecules involved are close together or touching or almost touching.